Hey, this is Andy Revkin. I write the .Earth blog for the New York Times. This is my 30th year trying to make sense of the human relationship to the climate system, problem system, both. And I'm catching briefly Ted Pfeffer, who is at the University of Colorado, a professor there who's been involved for a very long time studying the interface of big hunks of ice, glaciers particularly, the climate system and oceans, which is this grand formula that gets you a lot of sea level rise depending on what happens. The part of this TAD that seems pretty like as simple as arithmetic is a warming world equals less ice equals higher seas. And when you have the kind of warming we have, that can go on and will go on for a very, very long time. But what seems to be hiding behind that often is that the question of how fast that can happen is more complicated. And there's a new paper by Jim Hansen and 16 others, including Eric Rigneau, who's a longtime ice guy too. And there's a lot of conversation around it. What I'm trying to do is focus on what's in the paper, and how it relates to what's already known. And whether this, one of the core ideas is you can have very rapid sea level rise, a multi-meter rise within a century. It doesn't say this century anymore. The paper there was kind of a draft of it that said by 2100 we could have multi-meter sea level rise. It would be likely, is the term they used. That's not in there now, but the conversation still largely around this notion that we're facing sort of a coastal calamity here of epic proportions. So just backing up and can you give us sort of your summary of like what we learned about that question, both the reality of the long term and the questions about shorter term?
My very quick reading of the paper, because I didn't go carefully through the technical details. It's a long, it's a complex paper. One thing that impresses me about it is the attention to many, many details and many different processes that they've given to the analysis. And that part, that's very good. But they are looking toward a future where the possibility of the Antarctic ice sheet in particular producing very, very large rates of sea level rise, several meters in a century. They're doing this in part by comparison with the past, which is the applicability of the past to the present or the future is limited, but it's definitely there. They've made some very strong statements about what the future rates of sea level rise might be, but they haven't said when this is going to occur, and that is critical in my view. If you look at this from the point of view of somebody who's trying to use this information for anything other than scientific satisfaction, whether or not these very, very rapid rates of sea level rise happens in the next few decades or the next few centuries makes all the difference in the world. And the last time that the question of when does this start was not really addressed in this paper that I can find, and has been addressed only peripherally in most of the papers about ice sheet instability that I've seen. Ian Yockin made some statements recently that I thought were pretty solid about it being a few centuries before this kind of very rapid sea level rise can take place. And that makes sense to me because there are some very important things that you have to do in order to turn on the rapid response of the Antarctic ice sheet, to get rid of a couple of big ice shelves for starters. And it's going to take a few centuries to do that. From a strictly geophysical, glaciological point of view, a few centuries may not make much difference, but from the point of view of a planner, policymaker, again, these are the people that care about what exactly we're saying. It makes all the difference in the world. And that's the part that I find missing from this paper. They have to say something about when this is going to occur. They may not be able to say with any great precision, but they have to say something, because if this is something that's going to happen in the next few decades, yeah, it's something we've really got to wake up and pay attention about, if it's something that's going to happen in the next few centuries, then there are a lot of other issues that we have to sort out first.
Now, they reference a paper that I looked at, I think it was in 2009. I'm blanking on the name of the author right now. It was in some Yucatan corals, where during the Eemian, that last warm period.
Yep, and I'm blanking on his name too. It'll come to me.
Yeah. Anyway, he claimed to have found evidence of very rapid period of sea level rise.
Yeah.
And I don't know. I was trying to look to see in the literature if there's been subsequent work bolstering that or questioning it, or whether there's anything else that's come along that for you does present a kind of a vision of that there is a mechanism and that could generate something within a few decades.
Yeah.
Is there anything out there that hasn't been, that is presented or
nothing that I know about has come down the line recently. And that paper that you're talking about, Blanchon, skies.
Right, that's right.
The crucial thing there is that back in the Eemian, when we're looking at paleo records, a moment in time is on the order of 1,000 years. So again, hand that to a policymaker. The difference between 1,000 years and 100 years is all the difference in the world. And also, once again, there's the question of the lead time before this very rapid action takes place. There's no question about the importance of what these big dynamically unstable ice sheets must do. But when you translate it to human affairs, which is why we're doing this work, or it's why we should be doing this work, you've got to be able to say something about when. Either it's going to be imminent, or it's going to be some point in the future, or we don't know.
Right. And that's where things get, that's where these details and how things are spun or described, not just by the authors, but by the sort of the wider community, you quickly get into this, at the very least, misinterpretations, and sometimes maybe mischaracterizations, the difference being one being unintentional and one being intentional. And we've talked about this before, and I remember I quoted you a few years back on an article about whiplash in the science world, where, but it's the same issue where, and I, having watched this science for a long time, I don't really see something new yet. And this paper, of course, has the other question of not having gone through peer review. So, so separate from the question of, sorry?
It's a whole other box of worms.
Yeah. Now,
I mean, the review, but go on.
Well, you're moving to Washington for a while. I mean, in other words, you've crossed over to learn more about that universe of sort of where the information goes. So I assume, just explain a little bit about what you'll be doing.
Yeah, I've got what's called a Jefferson Fellowship, which is it's a program which is operated by the National Academy of Sciences. And the idea is to put senior scientists in advisory capacities in the State Department or in USAID. And there are about a dozen of us each year. And I'm coming in this year. I'm moving to DC to stay in about a month. And I'll be working with some office in the State Department or USAID. It actually hasn't been decided yet. They're just going through that now. Mm-hmm. And my particular interest in doing this, and why I entered the program to begin with, is that I've worked for quite a long time now on trying to do science and steer science in a way that we're providing information which is actually useful to policymakers and planners.
Right.
And I decided that I've gone about as far as I can go with that idea, and now I want to try to look at it from the policymaker's perspective. So if I can't persuade scientists to work on things that are useful on the time scales where we can actually make some decisions, I'm going to go over to the policy side and see if I can get the policy people to ask the questions that will motivate scientists to do that work.
Do you think there are certain questions that have been so so intractable for so long? One is climate sensitivity, which is essentially kind of in that same range it's been, with very little what I would see as policy relevant narrowing for a number of decades. And this issue of sea level rise, look back at the piece I wrote in 1988 about global warming. It was kind of a meter in a century was sort of the projection at that time. It was sort of rough outlines, not, and the science remains in a state where the key questions, like the paleo evidence on rapid sea level change just isn't granular enough to give you what can happen in a century, and the basics are still clear cut. Thousands of years of rising seas, at least many centuries before, even if things stabilized some. So if you're well, you'll learn more perhaps in a few months. But if I'm a policymaker, that tells me, one, I shouldn't count on waiting for another IPCC round for some magical aha moment.
Yeah, unless something big changes in the scientific world.
Right, and I guess there you never know it until you know it. But could you even envision something in the ice sheet dynamic world or coming around? Is there a proxy out there waiting to be discovered, or is there anything that you think could fill in that gap at that scale?
Oh yeah, absolutely. Just as far as understanding the paleoclimate world, no, I think that those people are doing the very best that they can. But in terms of trying to get a handle on what may happen in the future, there are a lot of tools that we could be using that deliver very different results from what we're doing right now. We're dealing with highly complex models that answer questions at a very high level of detail, and they're very difficult to build, they're very difficult to validate, they're very difficult to operate, and they're also very difficult to get the kind of information that's needed to provide boundary conditions and constraints for them. But there are other ways of looking at these systems that are simpler, that can be tailored to give you the information that you need, like how long is it going to take. Let me give you an example. One of the things that has to happen before most of what we're talking about with the West Antarctic ice sheet going into any very rapid state of decline is we've got to get rid of the big ice shelves, the Filchuroni and the Ross ice shelves. These are very different entities than the ice shelves out on the Antarctic Peninsula. They're a great deal thicker, they're a great deal colder. It's going to take a long time to get rid of them. We don't know how long exactly it's going to take. So one question to be asked is exactly how long does it take and what does it take to get rid of those ice shelves? I don't know that anybody's working on that problem in those terms. The treatment of ice shelves is a very important part of ice sheet modeling. But if you're just focused on the question of how long does it take to get rid of a very large, very cold ice sheet, very large, very cold ice shelf, I don't think anybody's doing that. And that's sort of the first thing you have to do if you want to find out what the time lag is going to be between today and things really breaking loose.
Why isn't that a big focus?
I don't know. You tell me. It seemed to me like it's kind of a ripe idea.
Yeah.
Are we actually live, or can we break for a second? Somebody's knocking on my door.
I can stop. I don't know. I think when I stop it, it just goes on to YouTube the way it is, and then I can. If we could maybe do
I'll
one.
ignore.
Okay.
I'll ignore it.
If there's a fire or something. Then.
Yeah, right. That's one example of a different kind of question that could be asked. There's also a lot of different kinds of approaches to these problems that could be asked. If I can back up just a little bit, I think that the way we approach glaciological modeling with large, complex 3D models is based on, I think it's based on the very notable success that atmospheric modelers have had with that approach. If you go way back to the very beginning of glacier modeling, ice and sea level rise modeling in the 1970s, and it started then because that was when we first had climate models that could tell us enough about the future temperature to let us ask the question of what might sea level do, because it all boils down to temperature, whether it's temperature causing declines in the ice sheets or temperature causing thermal expansion. At that time, there were these numerical models that were really working very, very well in the context of the times for atmospheres. And I think that the glaciologists took a look at that modeling style and said, let's do that. And we've done that ever since. And there's been I think, a lot of inertia and a lot of unwillingness to break out into other, basically non-deterministic modeling strategies that I think could tell us a lot about these questions. But we have to step away both from the questions that we've been asking for a while and also the tools that we're accustomed to using. That's not easy for people to do.
Maybe there's a need here for some break in the conversation and a new getting people together to brainstorm and some new priorities.
Yeah, that would be very worthwhile. And of course, it's hard to do now because there are so many people involved. It's become so large. You know, the IPCC. This is a very crowded, competitive field with a lot of established habits. You compare fifth assessment with the first assessment. You know, the first assessment, probably one person could hold the entire contents of the first IPCC assessment. Yeah. You can't do that now.
Yeah.
And so we've lost a lot of flexibility.
Well, that's interesting. Path dependency is what economists call it.
Yeah.
I recently, this is just a side note, but there's a paper in EOS that I'm going to write about some of the people involved with earthquake hazard prediction assessment got together at the Powell Center, which I didn't even know existed in Colorado near Fort Collins. It's a center for hashing out new approaches to complex questions. Yeah. And because they had faced a logjam and some failures in predicting the Haiti earthquake, Fukushima, the one off Japan, and so they had a methodological kind of smackdown. And over a period of 2 years, 4 meetings, and I think it's really interesting because when you read, I'll write a piece about it. The model for breaking through some of the barriers between not just between disciplines, but between people within disciplines who are kind of at loggerheads was really interesting. So maybe this is an area where that's useful.
That could be very useful, yeah. Yeah,
I just want to circle back to the paper one more time because a big part of it was about this ocean circulation, fresh water, sort of big pools of cool fresh water introduced to the models and the presumption that, and then also they sort of say that what they were modeling was what we're seeing now with some of that freshwater expansion around Greenland and that kind of thing. I don't know if you had time to look at that part of it much, but
not in all detail, no.
Okay. Well, all of it will be nibbled at. It's up for open review till mid-September, and hopefully people will weigh in. It's a sort of
it's a sufficiently complex paper that it could use the attention of a lot of reviewers. And I hope that all of the reviewers that are involved are both on top of the subject and looking at it from as broad an objective point of view as possible. Of course, it's supposed to be true of all reviewers, but it isn't necessarily.
Well, one example that just came my way from a scientist I know from the Anthropocene Working Group, who's a stratigrapher. I'm on that group. He said there's part of the paper that talks about extreme storminess, and one of the main things they mention is these giant boulders washed up to high elevation in the Bahamas. And he pointed me to some literature pointing to that possibly being from the Great Tsunami from when the Canary Islands collapsed. So there's a need for that cross-disciplinary question. If it was the tsunami and not extreme storms that move those boulders to where they are, then that's something that's important to examine at any rate.
Yeah. So, found that whole thing puzzling.
Well, we'll find out more. That's the way it works. And good luck in Washington. I wish you well. It's going to be an interesting experience.
Yeah. Well, thanks. I'll let you know where I end up.
Great. Bouncing back to science, or just moving to an island somewhere, or we'll find out.
Yeah. An island with high peaks on it.
Right. Exactly. Hey, thanks for talking with me, Tad.
Okay. Good to talk to you.